Hi, today we'll be presenting our practical data science project on factors that impact suicide rates worldwide. And I'm Bharat Prabhu and my partner is Philip Baker. So we'll be presenting a data set and machine learning exploration on how to predict suicide rates for different countries for different years and what features are most useful in doing so. And we'll elaborate on this later. The dataset we pulled was from Kaggle, which is known as a suicide rate overview from 1985 to 2016, and it contained socioeconomic information of suicide rates by year and country with various features such as GDP per capita, GDP per year, HDI, Human Development Index, so on and so forth. So it contained about 28,000 rows, which was pretty useful and large enough for a machine learning problem. So the first thing we did was essentially data cleaning, and as we see here, there are a lot of null values for the Human Development Index on a yearly basis. And we thought this was not good because based on a simple assumption that the more developed a country, probably the suicide rate is lower. It's just a very naive assumption to make, but it may be true. And so we don't know, and we want to include Human Development Index as a feature in our model. So what we did was essentially to pull out the human development data from the UN website from which contained Human Development Index values from 1990 to 2017 for 189 countries, and used this dataset to populate the original one to get rid of those null values because we thought HDI was an attribute that should be included in our model. The prediction questions, as I mentioned earlier, are essentially how well can we predict the suicide rate for a country in a given year and for an age group? And if we're able to do so, what features do we think are most useful in helping to predict that? And that's the question we'll be exploring today. So the first thing we did was explore the training data itself because we did not want to look at the test data at all. And what we saw was essentially, firstly, we saw that the prevalent notion that males tend to commit suicide at a higher rate or at a higher number than females is pretty much reinforced in this graph. You see that the male numbers are far larger than females. And an interesting thing is you can see the drop towards the end, and that's because the 2016 data is not fully available in the data set. But you can see the tapering off when it begins in 1985 towards 1995, and it just tapers off. What we also did was essentially a pairwise correlation plot of all of the quantitative variables, and I'd like to draw your attention to two specific plots. The first one is the top rightmost plot, and which essentially has GDP per capita on the x-axis and the suicide rate on the y-axis. And what this essentially shows is a logarithmic relationship where as the GDP per capita increases, the suicide rate decreases dramatically, but as it continues to increase, you can see the suicide rate decreases marginal, and this change is more highly seen for males than females. The second plot is essentially the HDI per year on the x-axis and the suicide rate on the y-axis. What you see is sort of a normal distribution. Surprisingly, when the HDI values go up from very low to about a mid-range, the suicide rate actually goes up, even though the country is economically developing, but as the HDI goes further up, the suicide rate starts to go down after that, and this is roughly around the 0.7 mark for the HDI, which is an interesting trend, and we thought we should include HDI in our model based on this cursory overview of the data. The third exploratory data analysis was essentially looking at the response variable on the training data, and we saw this huge right skewed plot for the suicide rate. It ranges from 0 all the way to 204, and most of these suicide rates range from 0 to 50. And we thought basically this informed us that we had to come up with the RMSE value, which is our measure from models. And thought we should come with the RMSE value that is small enough that gives value to all of the countries that are monitoring their suicide rates. And so the first model we fit is essentially a linear regression model on all of the variables, which is suicide rate trying to be predicted based on all of the variables we have in the training data set. And the train RMSE is 12.69, the test RMSE is 12.79. The test RMSE you see here is not the actual test data, but the test RMSE from the cross-validation on the train data. And we thought 12.69 as an RMSE is pretty high, considering that most of the suicide rates we see are 0 to 50. So 12.69 as an RMSE does not inform the suicide rate that well, and we thought we needed to reduce this significantly. So what we did was essentially to introduce a lasso regularizer, and the reason we did this was because our data set, after doing a binary encoding of all of the categorical features, expanded from 12 to 116 features, and we thought most of these features might not be useful and might be adding unnecessary variance to the data. So we introduced a lasso regularizer that increased the bias and reduced the variance. So what you see here is once we introduced that, you can see the RMSE stayed the same at 12.69, but we managed to remove 5 features, which is good because these 5 features were essentially useless in the model. So the next thing we decided to do was, why not try to feature engineer? Why not try to make use of the trends that we observed in gender, in HDI, and now in this plot, as we can see in generations between the GI generation and Generation X, which are showing the most skew and the most differences between male and females compared to all of the other generations, which Generation Z, which is my generation, almost completely indifferent. So we thought, why not group and add features based on these different trends that we're seeing? So the three new features we decided to add are pretty much the previous year's average suicide rate, the previous year's average suicide rate for the middle four generations of people, and the previous year's average suicide rate by gender. And the reason why we decided to add these three features was a basic, simple assumption, which is that economic development in a country year on year is probably not going to have a dramatic improvement in the suicide rate from one year to the next. So we thought, why not make use of these previous year's data, specifically by gender and by generation, and looking at the differences that we have seen from the EDA, and engineer those as features in our models and see if they make a difference in how we're able to predict the suicide rate for future years. So the third model we built was essentially added these three new features, and we built a lasso regularizer into that model as well, just in case that we were to find any dummy variables. And what we essentially found was that the RMSE dropped to 11.27, and we managed to remove 75 features, and most of these were the binary encoded features of different countries, which we thought were useless, and they ended up being useless based on this model. So the RMSE reduced, and we managed to remove close to 75 out of close to 120 plus features, which is very useful. And the final model that we decided to do was essentially a k-nearest neighbor regression model. The reason why we decided to do that was just based on this assumption that a country which has a similar human development index value, a similar gender ratio, and a similar makeup of people across generations might probably have a similar suicide rate. It's a very naive assumption, but we thought it was worth a try. So we did that, and we chose k is equal to 4, which is the number of neighbors based on cross-validation. And this model, including the engineer features, you can see that the RMSE dropped again to 10.16 on the trained data, but we decided on this model as our final model because we thought this model had the best chance, and voila, you can see the actual test data, which we have never tested on before. This model reduced the RMSE from an initial 12.69 that we saw earlier to by half, to about a 6.46, which is very useful, meaning that the standard deviation of the residuals for most of the countries that have a suicide rate between 0 and 50 is just 6 people. 6 people as a ratio of 100,000 people in their population, which we thought was very useful. So what are the conclusions we made from the final model and the engineered features and the prediction was that the HDI value that we decided to populate was crucially important in helping to predict the suicide rate. And the second thing is GDP per capita, as we saw in the EDA as well, was also an important based on the logarithmic relationship and the assumption that the more an income a person makes, the less likely he or she will commit suicide. And the last and most important one was the power of good new features based on the EDA that we saw the differences in generation, the differences in gender, the differences in human development index. Creating new features based on these differences and using those to predict suicide rates was tremendously useful. Thank you. That's the end of our presentation.